now like to address the first major conflict of interest as I appear to be chairing myself. So I think, Susan, if you can keep it to time, because I know you'll keep me in order. I'm going to talk a little bit about the impact of sugar on appetite regulation. I'm going to zoom out a bit to talk about appetite regulation in great detail. People have made statements about satiety and satiation and things like that. I think it's important that we know what they are when we're talking about them. Now, if you look on the programme, I'm also talking about the marketing of food to children. So I appear to be doing 2 talks in 20 minutes. So if I go a little speedily, I do apologise, and I can cover any omissions or problems, perhaps not necessarily in the panel discussion, but afterwards. Okay. Now, I think we all know what we think we're talking about when we're talking about hunger. Perhaps less than we're talking about satiation and satiety. And here's probably appropriate me to thank Dr. Graham Finlayson for this slide, who actually has attributed it to me, which is lovely. I wish lots of people would work and attribute things to me. Hunger is the drive to consume. Okay, in pure homeostatic terms, we can think about it. It elicits a response. That response is eating, and it sustains it. It perpetuates that eating behaviour. It's a response to a biological need, but it also has a strong habit and situational context. And when we talk about advertising, we talk about children, I'll come back to that point. Satiation is the process during a meal that generates the negative feedback. So it's counteracting that hunger which is continuing, and it's building that feedback which brings that meal to an end. So it terminates. So satiation is within that eating episode. And by and large, the major component of it is physical distension, although there is some early detection of absorptive nutrients, glucose will be one example. But it's important also to say that prior expectations and previous experience have an important effect on satiety. A lot of what you eat, or the size of what you eat, is about your beliefs about how filling potentially this food will be. And we're usually quite good at guessing that because we've eaten tens of thousands of meals over our lifetime. Then there is the end state of satiety, which is where one of the major issues around sugar will be, and that's the further suppression of the drive to consume after the meal. So it delays the return of hunger, and it delays the onset of the next meal, and or reduces the size of the next meal. And obviously there is gut regulation, the passage of nutrients, GI hormone release, microbiota, as Robert pointed out as well, metabolic effects, and all of these things inform that experience which feeds back to those cognitive effects on appetite. Now, the way we understand it, certainly as psychologists or biopsychologists, is something called the satiety cascade, because psychologists are very interested in events through time. So we want to know what triggers an eating episode, what underlies the start of an eating episode, what continues it, what brings it to the end, and what inhibits further intake. And certainly using the satiety cascade, we can understand the cognitive, sensory factors early on, but also the pre-absorptive and the post-absorptive factors, and a lot of that biology you've already talked about. But I think what's also important is we need to understand how these signals feed into the brain and how they affect that balance between the homeostatic mechanisms and the hedonic mechanisms, because it's where we have a mismatch there that we begin to see the problem with overconsumption. Now, there are lots of different ways carbohydrate is regulated and feeds back into the appetite system. I'm not going to talk about that. You will have plenty of information on that throughout the day. But what I will say, first of all, when thinking about carbohydrates and thinking about sugars, we have to think about energy density. Within a meal, energy density is important because we tend to eat to volume. So if we tend to eat to volume, and we put more energy in the units of volume that we are eating, we will overconsume. Very simply. Now the problem is, palatability and energy density are inextricably linked. You put more fat and more sugar into food, it is more palatable. It is also more energy dense. So you've already got a mechanism for passive overconsumption if you are eating by set unit. Okay? And there's some interesting studies, and these were done in Barbara Rawls's lab about 10 years ago now, and they're quite interesting. So what they've done is give people an ad lib meal, and in one condition they're not given any water to drink, but in other conditions they're given beverages. Some of them are non-caloric and some of them are caloric. Now what's interesting is, obviously if you give somebody a beverage to consume with their meal, if we follow the volume principle, their energy taken from the rest of the meal decreases because you've displaced it with the volume. But that effect is the same whether it's a caloric beverage or a non-caloric beverage. So you reduce the energy coming from the food component, but if that beverage has calories, then you add total calories to the meal. So that shows again how adding energy to a meal produces overconsumption if you increase the overall energy density of that meal. If you dilute it, you get a reduction. Then there is the issue of post-meal satiety, and here's where perhaps more of the controversy is. Now there is recognised a hierarchy of satiety where protein produces more satiety than carbohydrate, produces more satiety than fat, produces more satiety than alcohol. And within appetite science we have lots of debates about this because how you balance and construct the experiments can give you lots of diverse answers, and I'm not going to bore you with all that, but we'll take that as read. But what is important is within those macronutrient categories, there is a great deal of diversity to do with the form and the structure of those macronutrients. And I think that's one of the things which informs our understanding of how sugars affect appetite, and even how different sugars may differentially affect appetite as well. But what I think is uncontroversial is that we know, compared to complex carbohydrates, sugars produce a transient effect on appetite. They produce post-meal satiety, they do that, but they do it very quickly. And it is this transient effect which is at the heart of the problem. So if you look at the complexity of carbohydrate, or we look at it in terms of high and low glycemic doses, we do see that in the literature. What we know is replacing sugars with these more complex carbohydrates and or the low glycemic options, what it does is it produces initially a weaker effect on appetite, very much after the meal, but as we progress out, it has a longer duration, it has a longer tail, and it's the length of this tail which is critical, perhaps, in understanding overconsumption. And this is where perhaps we get into the more controversial area, or the more debated area in the appetite literature. Because the idea, or certainly the hypothesis is, if the effects of sugars on appetite are transient, then their effects on subsequent intake, unless that intake occurs very soon after their consumption, will also be transient, and you'll get incomplete caloric compensation. Well, what do I mean by incomplete caloric compensation? It means if you add calories at that meal there, and track them out to this meal here, if you are calorically compensating, the more calories you add there, the less you will consume there. Okay. But if you get incomplete caloric compensation, you don't get the proper adjustment at the second meal for the calories you consumed in the first. So that's all we mean by that phrase. Now, there are lots of studies which do demonstrate this. There are also a few studies which don't demonstrate this. And the literature is very confusing because the form the calories are given, you liquid or solid, the types of foods compared, whether there's appropriate control, whether they match for palatability, and I don't really want to go into those debates, but the literature has been critiqued by both sides of the argument. One of the important critiques which I would agree with is that these studies generally don't run long enough, and I believe you should look at appetite control across the day, and actually I believe you should look at it over long-term use of these things as well. Now, there's very few studies designed specifically, optimised specifically to look at appetite in terms of exposure to sugar or various forms of sugar chronically. You get appetite measures put into other studies where we're looking at weight management and energy intake. Appetite is measured in some of those, but it's not specifically designed for the appetite outcome. But what some of those studies do tell us is that if we replace sugars in a diet with, say, non-nutritive sweetness, thereby reducing the energy density of the diet, or we replace them by another form of carbohydrate, say starch, we get a reduction in body weight, or more successful weight maintenance, an absence of weight gain. That is associated with a difference in energy intake, and what is important, this might sound a little paradoxical, is there's no difference in appetite in either of those groups. Why is that important? Because it shows you can either take energy out or you can substitute the form of carbohydrate and reduce energy intake that way, get the weight loss, but there is no increase in the appetite, even though you've got that energy deficit, or that change in energy between the groups. So that sugar wasn't contributing all that much to energy. Now, with regards to the form of sugar, there is even more controversy. There's lots of appetite studies comparing, since the Teff paper, comparing fructose and sucrose and glucose and various things like that. And some studies show there are differences, and some sugar studies show there are not. I'm not going to go into that. I'll stick to the more global argument there. But what I will say is we need to think about things outside appetite regulation, the strict homeostatic. And those are the systems associated with reward, liking and wanting. And here, these are Graham's definitions and not mine, so this is his ownership, not me. What do we mean by wanting? Well, self-evident in a sense, but it's the hedonic motivation to consume a specific food, and it manifests itself explicitly and implicitly. Well, what do I mean by that? Well, it's a desire to consume food, a conscious element to it, but there's also an incentive saying, something that draws you to it, an unconscious urge as well. But to want something, you have had first to like it. So wanting is dependent on liking, and liking is the sensory pleasure elicited by the contact of the food and the contribution to that whole hedonic motivation to eat. Now, here we think about the hedonic quality of the food, but we also think about the sensory pleasing experience, and palatability is important in that. And what do we know? Well, we know from human studies that if we offer two people two meals, one is palatable and one is unpalatable, then what we find is anticipating consuming that palatable meal is associated with an increase in hunger, even post-meal, whereas the unpalatable meal doesn't elicit that hunger response. That in itself is obvious in one sense. And you can show that within a meal, that you can stimulate hunger within a meal if the food is palatable. That early stimulation of hunger when you have started consumption does not occur. Now, what's perhaps most interesting to me, palatable food stimulates hunger, but it delays the end of a meal. Why is it delaying the end of the meal? Well, it increases hunger, as I say, but also it delays fullness. Palatability, what link has that got to physical distension? But it does do it. It delays the fullness you feel within a meal, that volume effect. And also, interestingly, if we look at the bottom graph, and that intake graph at the bottom, you see the dotted line is the more palatable meal. Eating rate is quicker. And what we know is the faster you eat, the less associated that is with the normal development of appetite within a meal. And that's just normal people eating a palatable or a less palatable meal. Well, that profile is also similar to the profiles we see in the morbidly obese, just in response to general food intake. Now, I will return to animal models, and I know everybody's avoided them. And I just want to talk about what happens when you do chronically feed rats a highly palatable diet of sugar and fat. Well, this is what normally happens. You have the normal suppression of hunger signals and the normal increase of satiety signals, both from the GI tract, pancreas and the adipose tissue. They suppress hunger signals in the brain. That's normally what happens when you eat. The reward centres respond to that food. But look what happens when you're chronically exposed to those foods. What you get is, okay, a downregulation of hunger signals such as ghrelin and MPY, but you're getting an upregulation in the brain of hunger signals of orexin and ARGP. You're also becoming resistant to a number of these signals becoming into the brain. And then what happens is the balance between the hedonic and the homeostatic systems gets out of whack because dopamine and the opioid systems associated with liking and wanting are upregulated. So if we take a model of appetite where we have the biology on the left side, we begin to understand we have to consider the environment, which is on the right side of this diagram. And what we know from talking to the obese is, yes, we know that ingestants have an inadequate impact on their appetite, so they have poorer satiety within meal satiation. But we also know they feel less control over their appetite as well, and more driven by external factors. And it's those external factors we need to start focusing on. So we've got a broken system on the left-hand side, but we need to start focusing on the right-hand side. And this is where I get to the enjoyable bit, and I'll bend my timing rules a little bit. I'm not going to talk to you about the whole food environment because I don't study the whole food environment, but I came to studying one aspect of the food environment because of an accident. I was interested in this internal versus external drivers of appetite control, and we chose to use a fairly useful food stimuli, food adverts, and we chose to use children because unlike adults, when we do studies on them, their responses are normal. They don't adapt to change or give you what to conform to what you'd expect. And so we got into this area, and just by way of background, I'd like to say that TV viewing in the UK is increasing. So anybody tells you that children are watching less television, they're watching more television. They're just doing it while being on their computer and using their social media. And it's those three things coming together, which is how marketing is getting the children. Now, this, in the UK, we're meant to have the gold standard in terms of regulating children's exposure to food advertising. This is a basic analysis of the television children most watch, not children's television, important definition. The regulation deals with children's television. This is what children are actually watching, which is a different thing altogether. Now, as the regulation was coming in 2008, most of what children was watching was non-core. That's unhealthy. You can apply any nutrient profile modelling system you want, and Mike's done that for us. You still get that picture. Okay? So in non-peak and peak, there was lots of unhealthy marketing. Okay? The red, very little green. Regulation came in. It's still predominantly red, isn't it? Actually, the green's gone down as well. And what's happened is the marketing has changed around brand and less around food. So they've got around the regulation, but still the majority of adverts are unhealthy. What does this mean? Well, this is one of our many studies. Unfortunately, I'm limiting myself to one. And what it demonstrates is exposure to food adverts stimulate food intake. These adverts are standard adverts. We take them off the television, and they produce a robust response. They produce it in the lean, the overweight, and the obese. Obviously, in the overweight and obese children, the response is greater, but the response is still there. And those is amount of cake I'll eat it, and that's the reason is they're not increasing their volume so much, they're swapping to the unhealthy options. We give them a range of options and they swap to the unhealthy ones, the fat, sugar combinations by and large. Now, we did this research because we were interested in appetite, not because we were interested in advertising. But we got a letter demanding our data from the Advertising Association, although it wasn't sent to us, it was sent to our bosses, so we decided there was something in this, so we carried on. And we started... We have about, in terms of TV viewing, we have about 7 or 8 studies out there now, and we're moving on to areas of media which are perhaps more difficult to capture. But this is something which really, really concerns us, and it's the use of advergames aimed at children, because advergames immerse the child, okay, and they're linked to the brand. And there's a few studies out which talk about the content of advergames. It's very difficult to work out or measure their effects in the way that you can do with food intake. But this is a nice content analysis, and I think this one comes from Canada, but I stand corrected. Tim will know a little bit more about this. And what they did was analyse the content of a number of key websites, and what they found were advergames were pretty much on the most of them. The advergames immerse the child as the brands, with the brands, so they were completely subsumed in the world of brand information. Because they're rewarding, they get to various levels, so they repeat visit. They also post their high score, which is also rewarding, and they also use social media to get their friends to use it as well. So, we move from looking at television, which is one form, to this whole area of branding and marketing. And you can see all the forms of marketing down and branding down the left-hand side, and you can see all the levels at which we have to understand its influence. So we're at the start of a long journey. But to move back to our model, we can start filling in the right side, and we need to think about snacking and eating out and eating alone, cheap, readily available, easy to prepare food, all the things that we've talked about. But we're particularly interested in the world of advertising, both in the short and the long term, in the imbalance we see here. Because you have the passive overconsumption associated with volume, the active overconsumption associated with palatability, you have questions about post-meal satiety, but you've also, on this right-hand side, all of this pressure to buy and prepare. And I think I've said about everything I need to say, and I'm bang on half past, so we're nearly back to where we should be. But in summary, sugar contributes to energy density, leading to passive overconsumption. Sugars have a relatively transient effect on post-meal satiety, which could promote overconsumption. I would say most of the evidence points that way, but it's a complicated database. But what is important irrespective of that, is palatability drives consumption, and consumption weakens satiation, partly through that effect on volume. And what we know from animal models is it impairs the ability to respond to food intake. And I know I skipped over those slides a bit, but I wanted to get to food advertising stuff. And it also weakens, it also promotes the reward system. So your homeostasis, hedonic system imbalance is out of sync. Now, why is this important? Well, it's important because sugars are ubiquitous in the diet at the moment, and they're heavily promoted, particularly to children. So while I would not differentiate between sugars, and while I would not necessarily subscribe to a substance addiction model, and Robert would probably argue with me on those points, and they will do, I think it's rightly a key public concern for all of those reasons above. Thank you very much for indulging me.